Hello everyone, I am Kulansi Sadhu and welcome to my channel. I have uploaded KCL lectures in my previous videos. Hope you all enjoyed the videos. Now, today I will discuss something about the basic of electrical engineering. So, today we will discuss some basic concept related to electrical engineering. So, let's start with the first slide. First is classification of elements. So there are many types of elements you have learned or you have heard in your circuit network. So first of all, I want to discuss about the linear and non-linear elements. So what is linear element? An element is said to be linear whose VI characteristics follows only one equation of straight line passing through origin for all time. So clearly there are 3 points you will have to remember. One is it must follows only one equation of straight line. Second one is it must pass through the origin and for all time. So in the first example we can find that in the VI characteristics for the positive I you can get a positive V value, and the same you will get if you reverse the direction of current. That is, if you reverse the direction of current you will get the minus I, and for minus I you will get the minus V value of same magnitude. So you can find that in this equation here, as I is increasing, V is increasing, that is positive I and positive V, and when the I becomes negative, V also becomes negative. So it is always following a only one straight line equation, and it is also passing through the origin. Here you can see it, and for all time, it is following one and only one equation of straight line passing through the origin and for all time. So this is a linear element. And here you can find that though in the positive that is in the first quadrant, you can find that for positive value of I, the positive value of V you are getting, and also it is passing through the origin. But in the negative value of I, the value of V is 0. So that is, here it is not following the linear equation. So that is, here this is not following the one and only one straight line equation, because here the straight line equation is something which is not similar to the straight line equation here. So this is not following the straight line equation for all time. That is why this is non-linear element. Next one is active and passive elements. So generally active element delivers power to the circuit connected to them. Generally delivers power. That is, in some cases, if the circuit complexity or circuit requirement is such that the power could not be delivered by the active element, and then the power can be absorbed by the active element if the circuit requirement is there. But generally an active element always deliver power to the circuit connected to them. So example of active elements are voltage source, current source, battery. And passive elements examples are resistance, inductance and capacitance. Now if in VI characteristics slope is positive, then this is passive element, and slope is negative, then this is active element. What is the slope? Here you can find that suppose for the V value, for the I value, suppose this is 2 ampere, and for this 2 ampere we are getting a value of voltage that is 2 volt. So here slope is equal to what? b by I. Okay, so that is 2 by 2, that is equal to 1. So here what is telling that if the slope is positive, then it is passive element. So here it is passive element. Now come here. Here you can also find that for suppose this is minus 2 ampere, and you are getting the value, same value as it is linear, so you are getting the value minus 2 volt. So here also slope is equal to minus 2 by minus 2, that is equal to 1. So slope are positive in both the quadrant, that is first quadrant and third quadrant. So this is a passive element. And if you can find here, if there is something here, then you can find that V will be positive but the current is negative. So if the VI characteristic is like that, then in this quadrant you can find slope equal to negative, and if the slope is negative, then it is a active element. Okay, next is unilateral and bilateral element. Unilateral element and bilateral element, so which offers some opposition, this same opposition, that is the impedance, if the polarity or direction of voltage or current get reversed. So go through this one again, that here 2 ampere current is there, and for that you are getting 2 volt of voltage. So what is said, kindly say here, that offers same opposition if the polarity or direction of voltage or current get reversed. Now I am reversing the direction of current, that is minus 2 ampere, and here you are getting minus 2 volt, it is same opposition is there, so the slope is same. That's mean this is the bilateral element. But if suppose it is 2 ampere and you are getting 2 volt, and suppose you have reversed the direction of the current, and in minus 2 ampere current you are getting suppose 3 volt or 1 volt of voltage value, then the slope is not same. That means the opposition offered by the element is not same in if the direction of current or the polarity of voltage get reversed, then it is called unilateral. But if the element is offering same opposition or same impedance for the change in polarity or direction of voltage or current, then this is called the bilateral element. So from here you can find out that every linear element is bilateral, but converse is not true. Suppose this is a linear element, so here it is linear element is bilateral. Here linear element 2 ampere you are getting 2 volt, here minus 2 ampere you are getting minus 2 volt. So this is linear, and also the same opposition is there, so that is why it is also bilateral. But if you are getting for minus 2 ampere you are getting minus 3 volt, then the slope is not same and the opposition is not same. So if this is bilateral element, if the bilateral element is there, then there is no guarantee that the element is linear. But if the element is linear, then it must be a bilateral element. Okay, next is what time variant and time invariant. So what is time variant? If in the VI characteristics you can find that the VI characteristics changes with time. If the VI characteristic of the element changes with time, then it is called time variant, and if not, then it is time invariant. Here you can see that for this is for t equal to t1, this is your VI characteristics, and for t equal to t2 the VI characteristics has changed. That means for the change in time the VI characteristic is also changing, so it is time variant, and for time invariant it is not changing. Okay, so time variant and time invariant is clear. If any doubt is there, you must comment on the comment section and below the video, and I will try to solve it out. I will try to clear your doubt in the next lecture positively. Okay. Now another one is short circuit and open circuit. There are many students who get confused for the short circuit and open circuit behavior. So from first of all, here you can find that what is Ohm's law. Ohm's law is if the temperature and all other conditions remain unchanged, then the current flowing through the conductor is proportional to the potential difference across the terminal of the conductor, that is I proportional to V. If suppose there is question that V, what is Ohm's law? V proportional to I proportional to V, V equal to IR or I equal to V by R. If it is asked that which one is Ohm's law, then you must tick on this, that is I proportional to V, not V proportional to I, because in the Ohm's law it is stated that the current flowing through the conductor is directly proportional to the voltage across the terminal of the conductor. That is, if the terminal voltage changes, then the current will change, but if there is no voltage, then there will be no current. So current is dependent upon voltage. That is why current is the dependent variable and voltage is the independent variable. So I proportional to V is correct, V proportional to I is not absolutely correct according to Ohm's law. Okay. Now from here we can find out I proportional to V, that when I equal to V by R and V equal to IR, where R is nothing but rho L by A and rho is resistivity and rho is resistivity. Sometimes the question asked that if L and A get changed and R remain the same, then what will be the value of rho? That is there any change in the rho or not? So I am telling you that rho is the property of the material, resistivity is the property of the material, and it only changes with change in temperature. With this equation, rho T equal to rho naught into 1 plus alpha T, where alpha is the coefficient of temperature, rho naught is the initial rho resistivity and rho T is the resistivity at temperature T degree centigrade. Okay. So only get changed when temperature changes. Now here we can find out the circuit V equal to IR. V, current I is flowing and this is the resistance R. So V equal to IR. Now if R equal to 0, from here you can find if R equal to 0, then something divided by 0 equal to infinite. So I equal to infinite, that is maximum. So if V is here and R is equal to 0, I max equal to infinite, that is maximum current will flow, then the circuit will looks like this. This is the short circuit path. Okay. So in short circuit path resistance is 0, and when R equal to infinite, then something divided by infinite is equal to something divided by infinite equal to 0. So I equal to 0, that is minimum. R equal to infinite, I minimum. When current will not flow? When there is open circuit. If the circuit is open circuited, then the circuit is not complete, so no current will flow here. So I equal to 0. Okay. So that's all for today, and please try to remember this basic concepts, because sometimes this type of question are asked in GLET or if you are preparing for some PSUs. So this type of question you can also expect in the SSC JEE exam also. This year a question from linear non-linear element has come in the SSC JEE. So student, best of luck, and if you get this video interesting, then please like this video and subscribe to my channel Kallansis Sadhu. The channel name is Kallansis Sadhu, and this is the spelling of the channel. You can find out KALYANSHISSADHU. So please subscribe to my channel and like the video. Thank you all. Please go through the concept very attentively. Thanks all.